Hi all, welcome back to Excel's Rapid Focus series. It's me, Fairul, your math faculty. Today we are going to discuss the biggest chapter that you encountered in your entire life, that is integrals. Also, some of you may think this is the difficult chapter. Why? Why it is like that? Because the 95% or the 98% of the questions from this chapter is integrate some function, some rational function or some polynomial, some trigonometric function. So the question is like integrate something, integrate some function. Most of the questions is like that. But the problem, most of the problems is like that, but you get confused because solving that particular problem maybe vary from these 9 different types. So that you can expect 9 different types of questions from this chapter, but all of them looks like similar. That is one of the problem, my dear students, you face. So I just listed these are not the topics. These are not the topics from the chapter. These are the types of question that you can expect from each topic. Okay, let me explain what are the types of problems you can expect. Listen very carefully. Listen. First one, the results, because you know there is plenty of results, like integral of x raised to n is x raised to n plus 1 by n plus 1, integral of dx is x, integral of sec square x is tan x. You know plenty of equations, results like this. So use that result. They will make some questions. The results itself become a question. You can expect that in MCQ questions. So that is one type of question. And the second type is what? Direct integration. Use the result. They will give you some function. Use the result and find the answer or integrate it. And the third type is what? Integration by substitution. You can substitute. You have to substitute. You are not able to do direct integration. So that what you have to do? You can do substitution. Actually, there is 3 methods of integration. 3 methods. What are the 3 methods? First one, substitution. Second one, partial fraction. And third one, by parts. Listen. So the third type of question that you can expect is what? Substitution, integration by substitution. I'll explain all these kind of questions in there. So here, fourth one is what? Integrals of some more particular functions. I call it myself 3 plus 3 equations. 3 plus 3 equations. There is same kind of 3 questions. That same set repeats with a slight change. So I call it what? 3 plus 3 equations. And the fifth type of question is what? Variation from 3 plus 3 equations. So this 3 plus 3 equation, if you know this 3 plus 3 equation, you can answer lots of questions, but there is a slight variation from 3 plus 3 equation. So you have to do that question also to understand that is a variation from 3 plus 3. Okay, so slight different. There is a question that you are not directly able to use the 3 plus 3 equation, so that we have to do some more other things. So that kind of question is under the fifth part. So all these 3 types of questions is under substitution method. This method. Okay, substitution method. Okay, all these 3 is under substitution method. And sixth type is what? Integration by partial fraction. You have to know a table. I'll show the table. If you know that table, you can easily integrate it. A table is there. And the 7th one is what? Integrals of some more types. That is, we combine some of the equations that we derived before and combine that together. We will get a new type of equation. And the 8th one is what? Definite integrals. That is, we will have a limit for that, for the integration. All these types of question you can expect from indefinite integrals. And the 8th one is what? Definite integral. That means it will have a limit from integral a to b, from a point to other point. And 9th one is what? There is some properties. We have to use that properties to answer the question. So these are the 9 types of questions that you can expect. Now we can check what are the questions you can expect from each of these types. Okay, let's dive into that. So the first kind of questions is from results. So that means the equation, actually I think you all know what is integrals, what is integration. It's an inverse process of differentiation. It's an inverse process of differentiation. What does that means? What does that means? You can see here the derivative of x raised to n plus 1 by n plus 1 is equal to x raised to n. Then the integral of x raised to n, integral of this x raised to n will become what? X raised to n plus 1 by n plus 1. So derivative of sine x is what? Cos x. And this answer, integral of this answer, integral of cos x dx become what? Sine x, the function. So the opposite of integration is the opposite of differentiation is what? Integration. So in other words, if a function is differentiated, if you integrate that answer, the differentiation will be cancelled. You will get f of x plus c. There will be an integrating constant while you are integrating, because while you're differentiating, if there is a 5, that 5 is differentiated into 0. So while you're integrating, it may be 5, 6, 7, whatever it is. So we consider it as a constant. Sometimes it's maybe a 0. So opposite of this is what? Integral of f of x dx will be, and if you differentiate this, what you will get? F of x. So integration as an inverse process of differentiation. So from that logic we derived all these results. I hope you all know these results. Take a screenshot, or in your textbook you can see these equations, all these equations. Sometimes some of these equations come as an MCQ. You can expect that. Okay, so and the second type, the first type is results. You have to do what? You have to by heart the results. That result itself come as an MCQ. You have to answer that. So you don't need to do much calculations or anything. You have to memorize it. You have to answer it. That's the first kind of question, easy kind of question. And the second kind, direct integration. How do we integrate directly? So here is a question. I have to integrate. I is equal to integral e raised to 2x plus x dx. So if there is two functions, you can separately integrate that two functions, e raised to 2x dx plus integral x dx. Actually you have to do substitution here, but without doing substitution we can do this problem. How we can do that? Integral of, what is integral of e raised to x? You have to know that integral of e raised to x is what? Integral of e raised to x dx is what? E raised to x itself. So I'm just giving you derivative of e raised to x is what? I'm just telling you this. Derivative of e raised to x is what? E raised to x. Then integral of e raised to x is what? E raised to x. Using that idea, you can have you can get this results. So listen, but here it is 2x, right? What do we do if you get like that? If integral of e raised to 2x dx is, what is integral of e raised to x? E raised to x is what? Integral of e raised to x is what? E raised to x itself. But e raised to 2x is also e raised to 2x itself. But the derivative of the one at the one who replaced x, the derivative of one who replaced x, here this is x, but here it is 2x. That means the one who replaced x is what? 2x, and the derivative of 2x is what? 2. So you have to divide that 2 here. Okay, you have to divide that 2 here. The one who replaced x is 2x. We differentiated that, we divided it. In differentiation, what we will do? Derivative of e raised to 2x is what? Derivative of e raised to x is e raised to x. Derivative of e raised to 2x is what? E raised to 2x itself. What is the derivative of the one who replaced x? It's 2. So we multiply it. In differentiation, we multiply, chain rule. In integrals, we divide it. But only if the derivative is a constant. Here it is a constant 2. Only if the derivative is a constant. Otherwise, it's not allowed. We have to use any of the methods that I mentioned before. Ready? So this is only allowed, the division of the derivative is only allowed if the derivative is a constant. Otherwise, if it is 2x square, The derivative of 2x square is 4x. So it's not a constant, it's a variable. It's not allowed to do like that. You're not allowed to write 4x at the denominator. Understood? So it's only allowed in integrals if the derivative is a constant. So that, what is your answer here? Tell me. Integral of e raised to 2x is what? E raised to 2x itself. But the derivative of the one who replaced 2x is what? 2. It's a constant, so we divide. Plus derivative of x raised to 1 is what? X raised to 1 plus 1 by 1 plus 1 plus c. It's like integral x raised to n. I hope you all know integral x raised to n dx is what? X raised to n plus 1 by n plus 1 plus c. So here instead of n we have 1, so x raised to 1 plus 1 by 1 plus 1. So your final answer is what? I is equal to integral is equal to e raised to 2x divided by 2 plus x square by 2 plus c. Okay, this is your answer. If you want, you can write it like e raised to 2x plus x square divided by 2 plus c. If it's an MCQ question, you will get the option. As per the option, you can write like this way or that way. Understood? So we can go to the next question. So this question is also from direct type. Remember what we are doing? The result we discussed, the direct integration. What is a direct integration? So the first direct integration we have done, and the second direct integration question is what? I is equal to integral e raised to 5 log x dx. E raised to 5 log x dx. So to do this question, you have to know one property of log. It's n log x is equal to log x raised to n. If there is a constant in front of it, you can take that into top. If there is a constant on the power of x, you can take that in front of the log. So we will use that property in both the ways. But here we have a constant here, so I can take that in on top of that x dx. So I took this 5 to the top of x, and one more result, e raised to log x is equal to x. Also log of e raised to is also x. These two will be cancelled. Log and exponential function will be cancelled if the base of the log is e. It's fine. Most of your question, the base will be e. So these two will be cancelled. You will get integral of x raised to 5 dx. Last question, I explained what is integral of x raised to n plus 1 by n plus 1. So it's x raised to n plus 1 by n plus 1. N plus 1 is what? 5 plus 1, it's 6 by 6 plus c. So this is your answer. There is an option like x raised to 6 by 6 plus c. Okay. So these are the direct kind of question. If you know the result, you have to know which result integral of x raised to 5 n. Sometimes they will give you a function like f of x equal to sin x plus cos x or something. So if they ask you for integral of f of x dx, what is integral of sin x? It's minus cos x. What is integral of cos x? It's plus sin x. Okay, so it will be sin x minus cos x is your answer. Plus c will be there while you are integrating constant. After integration, you have to put plus c. So if you know the result, you can directly integrate the thing without doing any other things. That is a direct integration questions. Okay, so we can go for the next one, that is integration by substitution. This is the important one. Ready? Because substitution is used within partial fraction, by parts, and definite integral. All other part or all other kind of questions is having what? This integration by substitution. We have to substitute here and there in lots of questions. So here I am going to do one question, that is I is equal to integral x square e raised to x cube dx. Okay, so what is the substitution? You can see there is two functions is there. Also there is another function on top of exponential function. There is a composite function here and another function is there. It's a mixed one. It's not a direct question. It's not integral of something x raised to n or x raised to 1. It's a complicated one. So mixed or something. So here what I can do is, if I can see, if I put t is equal to x raised to 3, what is the derivative of t? dt by dx is what? 3x square. So what is dt then? 3x square dx. Ready? So we have x square dx here. So I will take this 3 to this side. 1 by 3 dt is equal to x square dx. So what is the catch? If you differentiate something, some function inside this, the derivative of that is also should be there. So x derivative of x cube is what? 3x square. So x square is there. So x square is there. That variable is there. Whatever the constant, you can take that into this side. So you have to get, if you substitute x square, if you put t is equal to x square, you will get 2x only. So the 2x is not here while you substitute x square. But when you put x cube as your substitution, 3x square, x square is there. So that's how we identify which to substitute. The derivative of the substitution that you are giving, that should be in the question. So then I'm applying that substitution. What I will get? I is equal to integral x square into dx. What it is? X square into dx become 1 by 3 dt. 1 by 3 dt. And e raised to x square into dx become what? So these two guys are gone. And e raised to x cube is there. E raised to x cube. X cube is what? T. So what I got? In 1 by 3 integral e raised to t dt. Integral e raised to x dx is what? E raised to x. Integral e raised to t dt will be what? E raised to t plus c. So what is t? What is your substitution? X cube. So e raised to x cube. We have to put back that here. All divided by 3 plus c. So what it is? E raised to x cube. E raised to x cube by 2 by 3 plus c. So that's your answer. Next question. So it's also a question from substitution. Integral e raised to x into 1 plus x by cos square x times e raised to x. This is inside cos, the inside cos. And how do we do that? So we have to integrate I is equal to integral e raised to x into 1 plus x all divided by cos square x e raised to x dx. Listen, let me open this bracket. So what I will get? E raised to x plus e raised to x into x all divided by cos square x into e raised to x dx. Listen, what did I said before? If you substitute something, the derivative of that thing should be there. Can you identify anything like that? Here it is t is equal to x e raised to x. So derivative of that, it is derivative of this is, we have to apply product rule. First function into derivative of e raised to x is e raised to x. Second function e raised to x into derivative of first function, that is 1. So e raised to x plus e raised to x into x, e raised to x into x. So what you got? dt is equal to e raised to x plus x into e raised to x or e raised to x into x, and this dx goes over there into dx. So you can see that e raised to x plus e raised to x into dx, that all thing become what? dt. Then I is equal to what? Integral. This all thing become what? dt. So numerator, there is nothing, only 1 divided by cos square. Instead of x e raised to x, we have to put what? T. We have to put t. So 1 by cos square x is what? Sec square t. What is integral of sec square? From the results page, you can see that integral of sec square is tan t plus c. So what is t then? What is t? We substituted t as what? X e raised to x plus c. So guys, if you want to answer questions from this chapter, you have to know differentiation. In integration chapter, there is differentiation also is there, not only integrals. If you can identify the derivative of this is this one, then only you can substitute the thing. Okay, so this is how substitution works, and these kind of questions you can expect. Go through your reader and you can find questions similar to this. do all the kind of questions under substitution. Now we can go for the next part, that is integrals of some particular functions. Using substitution, we have developed 6 new equations that are shown here. Listen, the first one is what? Integral of x square minus a square dx. Second one, integral a square minus x square, it's just swapped. And integral of x square plus a square. And what is the difference between these three and these three? We put root for all these three, we will get what? These three, the next 3 equations. So actually these are with no roots, these are with roots. That is the difference between the LHS. And listen very carefully, all these equation is having what? Numerator 1, numerator 1 into dx. That's why the dx is the numerator. All these equations have numerator 1. The numerator is always 1 and the denominator is having second degree polynomial that can be expressed as x square minus a square or a square minus x square plus a square. These combinations, these 3 combinations and root of that. That's why I called it 3 plus 3 equations. These 3 is one set and these 3 set that's similar to that. You have to remember like this, 3 plus 3 method. When you get a question, if the numerator is 1 and the denominator is having a second degree polynomial, that is the question that we can do using 3 plus 3 equations. That's how we identify that. Listen, you can see integral of 1 by x square minus a square, it's 1 by 2a log of x minus a by x plus a. You can see x minus a here. So a square minus a square, it's changed, it's swapped. So this is also swapped like that, a plus x by a minus x. You can relate that. And integral 1 by x square plus a square is what? 1 by a tan inverse x by a. I think you know this result already. This one is already you know, because integral of 1 by x square plus 1 square or 1 dx is what? Tan inverse x plus e. You already know from the results page. Instead of this a, we put what? 1. So what you will get? Integral of 1 by x square plus 1 square, that is 1. Integral 1 by x square plus 1 is equal to 1 by 1, that is 1. Tan inverse x by a, x by 1, that is 1. Tan inverse x, you will get what? Tan inverse x. So that is this is the general form of this equation. And while you put root on at the denominator, what you will get? Log of, and here also log, but only for root of a square minus x square you have sin inverse x by a. Both the other two is having what? Log. And this is also an equation that you are familiar with. If you substitute 1 for a, you will get 1 by root of 1 minus x square, that is sin inverse x. You already know from the results. So these are the 3 plus 3 equations. By heart this, take a screenshot and we can check what are the questions you can expect from these questions, okay, from these equations. So the first question is what? Find integral of this one. So how do we identify a question is we have to approach using 3 plus 3 equation format. It's I is equal to, you can see the numerator is 1, first qualification, numerator is 1, nothing else, only dx is there, numerator is 1, and at the denominator there is a second degree polynomial. These are the qualifications for what? Integrals of some particular functions or 3 plus 3 equations. 3 plus 3, 3 types of these equations, 3 types of equations. And in our question we don't have the square root at the denominator, so our question is come under any of these 3 equations. So listen very carefully, out of that 3, which one is ours? I will write like 2x the whole square. Instead of writing 4x square, I can easily write 2x the whole square plus 3 square dx. It's a simple question. So it's like x square plus a square, x square plus a square. So at the denominator, who is that? Integral of 1 by x square plus a square. It's 1 by a tan inverse x by a. So we have to use this equation. Which equation? Which equation? Integral of 1 by x square plus a square, constant square, dx is 1 by a tan inverse x by a. This is how we have to identify which equation we have to use. Okay. So then how do we do this? So but instead of x we have what? 2x here. We can do directly by the derivative of 2x is constant, we can divide it, the answer of the integral by that. But we can do substitution here also. How? T is equal to 2x, we have to put 2x, but because we only have, in here we only have x, but here we have what, 2x. So what is derivative of 2x? dt by dx is 2. So dt is what? dt into 1 by 2 is equal to what? Dx. After substitution, I will be what? Integral of dx become 1 by 2 dt, 1 by 2 dt, numerator nothing is there, only 1, 2x become t square plus 3 square, and the answer will be what? 1 by 2, it's integral 1 by t square plus 3 square dt. It's like this, it's 1 by a, 1 by a is what? 3 tan inverse x by a, instead of x we have t by 3 plus c, which is equal to 1 by 6 tan inverse, what is t? T is 2x by 3 plus c. So what if I directly do this? Listen very carefully, that is a final answer. And what if I directly do this? Consider this as x, this as x. So how do we start? 1 by a, 1 by a is what? 3 tan inverse, instead of x we just use what? 2x divided by, instead of a we use what? 3 plus c. But the problem is these are not the answer, here it is 1 by 6. So how do we change that into this into that? So derivative of 2x is what? 2, we have to divide that 2, so 1 by 3 into 1 by 2, it's 1 by 6 tan inverse 2x by 3 plus c. Remember I told you before, if the x is replaced by any other function and the derivative of that function is a constant, then you can divide it. If it is not a constant, then only you have to think above. You don't need to go like this, you can go like this. If you understood the idea, if the x is replaced with any function, you can differentiate it that, and the derivative of that is a constant, you can divide it, you will get the answer directly without going for the substitution. Okay, otherwise you can go for the substitution directly. So we can go for the next question. So this is also a question that is using 3 plus 3 equations. So and substitution together, you can see what is the question. I is equal to integral sec square x by root of tan square x plus 4 dx. So first of all, I'm going to do substitution here. So t is equal to tan x. I can see the derivative of tan x at the numerator. What is it? Sec square x. So derivative of tan x is what? Sec square x, and the dx I will take to this side. So after that I can perform the substitution. What is the substitution? Sec square x into dx, sec square x into dx become what? Dt, and numerator there is nothing, root of t square plus this 4 can be written as 2 square. So listen, it's our 3 plus 3 form. Which part of 3? Numerator is 1, first qualification. At the denominator there is a second degree polynomial with or without root. Now we have what? With root. Which option? Which type? With root, any of these 3. Out of that I prefer this one, right? Because x square plus a square. In our question also we have what? T square plus 2 square. So what is that? It's log mod. It's log mod t plus root of t square plus 2 square plus c. So what is t? Log of, what is t? Tan x. Log of tan x plus root of tan square x plus 4. That's your answer. Okay, this is how we will do what? This is how we approach to the 3 plus 3 format. Okay, so what is the condition? The numerator will be what? 1, and the denominator is a second degree polynomial with or without what? With or without what? Root. So you can use any of these 3 set questions in there. Okay, now we can go for the next type of question. The next part is variation from the 3 plus 3 equation. I think you know what is 3 plus 3 equation right now, and here you can see what is the variation. In 3 plus 3 equation, at the denominator there will be second degree polynomial with or without root. But here also it's same. The denominator will be with or without root of second degree polynomial. But at the numerator there will be a first degree polynomial. In 3 plus 3 equation, you can see that the numerator is all 1, nothing at the numerator. In the question that we have done, you can see nothing at the numerator, only 1 at the numerator, only 1 at the numerator. Here also only 1 at the numerator. But in this case, the denominator is a second degree polynomial with or without root, but at the numerator there will be what? A first degree polynomial. Instead of 1, there will be a first degree polynomial. So what do we do then? We will just substitute px plus q, the numerator. The problem is at the numerator. The numerator is equal to constant a times derivative of the polynomial at the denominator. Don't use the root. Sometimes there will be root, sometimes there will not be a root. So we just use the polynomial, second degree polynomial plus b. So while you differentiate this one, what you will get? A times this plus 3 plus b. So instead of px plus q, we will use this one at the numerator. Then you can integrate easily. So we can look how do we do that in the next question. Okay. So this is the question. I is equal to integral x plus 2 by root of x square plus 5x plus 6 dx. Okay, the problem is the denominator is fine. There is a second degree polynomial with root, but the numerator is what? X plus 2. So what we will do, we substitute x plus 2 is equal to a constant a into derivative of the polynomial at the denominator without using that square root. Some question you will not have the square root. Whatever it is, you only need to take what? The polynomial plus b. Okay, it's like this form: a into derivative of the polynomial at the denominator plus b as your numerator. So what you will get? X plus 2 is equal to a times, what is the derivative of this one? 2x plus 5 plus b. So this is very important. We are going to use this equation as your numerator, but before that we have to identify what is a and b. How do we do that? X plus 2 is equal to, open the bracket with a, what you will get? 2ax plus 5a plus b. You can see the coefficient of x is 2a, the coefficient of x here it is 1. So 2a is equal to 1. And the constant term at the right side is 5a plus b, and the constant term at the left side is what? 2. So a is what? 1 by 2, we got a. And 5 into 1 by 2 plus b is equal to 2. So b is equal to 2 minus 5 by 2, it's minus 1 by 2. 2 minus 5 by 2 is what? Minus 1 by 2. So we got what? A and b. Now we are going to integrate listen. So I is equal to integral instead of this numerator x plus 2, I use this one. What is it? A. What is a? 1 by 2 into 2x plus 5 plus b. What is b? Minus 1 by 2, all divided by what is at your denominator? It's root of x square plus 5x plus 6 dx. Now from this, now I'll split the numerator as two parts, and I will give the denominator to this part and that part. Let me write it like that. So it will be like I is equal to integral 1 by 2 times 2x plus 5 all divided by root of x square plus 5x plus 6 dx minus integral 1 by 2 by root of x square plus 5x plus 6 dx. Let me take the constants out. Then what? 1 by 2. I took this 1 by 2 out. Integral of 2x plus 5 root of, all divided by root of x square plus 5x plus 6 dx minus 1 by 2 integral 1 by root of x square plus 5x plus 6 dx. For the easiness of the integration, I'll name it this integration as I1 minus 1 by 2, this integration as what? I2, and this will give you the answer I. So now we are going to find I1 and I2. Let me do I1 here. I1 here. What is I1? Integral of 2x plus 5 root of x square plus 5x plus 6 dx. This is I1. Okay, listen very carefully. What is derivative of x square plus 5x plus 6? It's 2x plus 5. So derivative of this guy is at there on the numerator, or in other words, integral of derivative is at the numerator and at the denominator root of the function dx. Function is at the denominator within the root and the derivative of that function at the numerator, then the answer will be 2 root of f of x. This is not in the results, but you have to add this in the result sheet and memorize it. So this is function, this is derivative, and the answer is what? I1 is equal to what? 2 root function. 2 root, who's the function? The polynomial x square plus 5x plus 6. So you got what? I1. I1. Now we need what? We need what? I2. How to find I2? So I2 is what? I2 is equal to integral 1 by root of x square plus 5x plus 6 dx. Listen, now we got the 3 plus 3 method. This is variation from 3 plus 3 method. From that, now this part become what? The I2 part become what? 3 plus 3. Numerator is 1. Denominator is second degree polynomial with the root. It comes under which category? It will come under any of these 3 category. So, but this should be like x square minus a square minus x square plus a square. But the problem here in our question, it's not any of that kind. It's not x square plus a square. There is x. In our equation, there is no x. Only x square is there. X square and a coefficient. So x square plus 5x plus 6. We have to write it like any of the 3 format. Any of the 3 format. What are the 3 format? Let me show it. What are the 3 format? The 3 formats are what? X square plus a square, x square minus a square, or a square minus x square. So what is our polynomial? X square plus 5x plus 6. X square plus 5x plus 6. So x square plus 5x plus 6 is equal to x square plus 5x plus 6. If you want to make this polynomial to any of these types, what you have to do is just take the half of the coefficient of x. Who? Coefficient of x. Half of coefficient of x. 5 by 2. 5 by 2. Half of 5 is what? 5 by 2. And add the square of it and subtract the square of it. Add the square of it, subtract the square of it. And this term will become what? Will become what? X plus 5 by 2 the whole square. 5 by 2 the whole square. If you expand this, you will get this. Okay. If this plus is negative, if it is negative, you have to put negative here. X minus 5 by 2 the whole square. Okay. Instead of the plus, if it is negative, you have to use negative here. Whatever the half of the coefficient of x, that will comes under here. Okay. Then the remaining part, these two will be what? Plus 6 minus 25 by 4. Okay. Well, let's cross multiply it. What you will get? X plus 5 by 2 the whole square plus 24 minus 25 by 4. It's minus 1 by 4. So I just write it like x plus 5 by 2 the whole square minus 1 by 2 the whole square. That as x square plus 5x plus 6. And listen very carefully, we got one of these. It's like x square minus a square. What is it? X square minus a square, this format. Integral of x square minus a square. Which one? Listen, you can see integral of 1 by root of x square minus a square. This format, log mod x plus root of x square minus a square plus c. So listen, you have to know that equation. Then let me rewrite this as integral 1 by root of x plus 5 by 2 the all square minus 1 by 2 the all square dx. And this is like integral 1 by root of x square minus a square. What is integral 1 by root of x square minus a square? I just shown before. It's log mod x. Instead of x, we have what? X plus 5 by 2. And the derivative of x, the one who replaced x is what? X plus 5 by 2. And the derivative of x plus 5 by 2 is what? 1 itself. So there is no constant at all. So nothing to divide it, just 1. So plus root of x plus 5 by 2 the whole square minus 1 by 2. So what is that actually? This is actually this one. So I just replace it with x square plus 5x plus 6 plus c. Okay, we have to write this here, but actually what is this? The polynomial. I just write the polynomial here. Now you got what? I2 also. Now you got what? I2 also. So we got I1, we got I2. So now we need what? I is what? Half of I1 minus half of I2. So I is what? Your final answer is what? Half of I1. What is your I1? 2 root of x square, the polynomial, 2 root of x square plus 5x plus 6 minus half of I2. What is your I2? It's log mod of that one minus log mod of x plus 5 by 2 plus root of x square plus 5x plus 6. These two will be cancelled. Your I will be root of x square plus 5x plus 6 minus 1 by 2 log mod x plus 5 by 2 plus root of x square plus 5x plus 6 plus c. That will be plus c. So this is your final answer. Okay, so this is a variation from 3 plus 3 equation. What is a variation? At the numerator there is a first degree polynomial instead of 1. What is our 3 plus 3 equation? Only at the numerator there will be only 1. At the denominator there is a second degree polynomial with or without root. Here denominator is fine. There is a second degree polynomial with or without root. It's with root. And at the numerator there is a first degree polynomial. That is our problem. So we took the first degree polynomial here and we applied that in this format. A into derivative of the polynomial at the denominator plus b, found a and b, substituted, split the denominator, then here always you will get an equation like this. Sometimes if you don't have root here, this will be integral of f dash of x by f of x, and I'll give you that result also here. Integral of f dash of x by f of x dx is equal to log mod f of x. If there is no root at the denominator, if there is root at the denominator, it is 2 root of the function at the denominator, at the polynomial at the denominator. So this is how we approach variation from 3 plus 3. Okay, we can go for the next. In this part we are dealing with the rational functions. This part is called what? Integration by partial fraction. Listen, remember this one. This is what? First degree polynomial into first degree polynomial. So when you multiply a first degree polynomial with a first degree polynomial, you will get a second degree polynomial. At the denominator, what is it? Second degree polynomial. At the numerator, what is it? First degree polynomial. Denominator, second degree polynomial. Numerator, first degree polynomial. We already know that. This one, denominator second degree polynomial, numerator first degree polynomial. We can do this as a variation from 3 plus 3. Actually, if you get a question like this one, you can use a variation from 3 plus 3 to do this one. But the difference between that and this, look at this. At the denominator, it's like two first degree polynomial. That means the second degree polynomial is factorizable. Second degree polynomial is factorizable. Factorizable. Listen. So if the denominator is factorizable, we choose what? Partial fractions. Partial fractions. Listen. So first factor is what? At the denominator x minus a. Second factor is what? X minus b. So a by x minus a plus b by x minus b. That's how we can write it. Understood? So listen very carefully. The second thing is what? At the denominator is second degree polynomial. Yeah, when you open the bracket, you will get second degree polynomial. But both the factors are same. Both the factors are same. X minus a into x minus a. That will become what? X minus a the whole square. So at that time, the partial fraction form is what? A by x minus a plus b by x minus a the whole square. Don't write what? A by x minus a plus b by x minus a. It's what? A by x minus a plus b by x minus a the whole square. Okay. Then here, and the use of partial fraction comes here because it's third degree right now. We can only 3 plus 3 equations and 3 plus 3 variation only help you to do till the denominator is second degree polynomial. But here you can see it's third degree, 1, 2, 3 factors, and 1 less than at the numerator. What is it? Second degree polynomial. So we can write a by first factor, b by second factor plus c by third factor. What about this one? Out of these three, two of them are what? Equal, and third one is what? Different. So a by x minus a, like this one. A by x minus a, b by x minus a the whole square. But we have one more guy here, x minus b, so plus c by x minus b. Ready? In other words, the last fifth type is what? One factor, and second one is what? It's a second degree polynomial that is not factorizable. We are not able to factorize this. So what we will do? We'll write a by first factor plus at the denominator second degree, and the numerator it will be what? First degree, one less than it. bx plus c. Then we can do that. Easily we can do that. We can use 3 plus 3 variation to do this one. Okay. So this is partial fraction. I'll do 2 questions. Then you will understand how do we approach this question. So listen. This is a question that asked in your board exam so many times. So how do we do this? I is equal to what? I is equal to integral 1 by x into x raised to n plus 1 dx. How to do this? So here I have to before going to partial fraction, I have to do some substitutions. So if we substitute t is equal to x raised to n, I don't have any other x raised to n here. Okay, there is only one option I can substitute, that is t is equal to x raised to n. Then only it can be simplified. So before that, I have to do a little bit of manipulations. What is it? I'm going to multiply the numerator and denominator with n into x raised to n minus 1, n into x raised to n minus 1. Why did I do that? Why did I do that? Now, what is at the what is on the numerator? At the numerator, what is it? nx raised to n minus 1, and x raised to n minus 1 into x is what? X raised to n minus 1 into x is what? X raised to 1 is what? It's plus 1, and into x raised to n plus 1, and there is a n here. I'm going to take that out as a constant dx. I didn't take this n. I'll explain why it is. Integral 1 by n integral is equal to 1 by n integral nx raised to n minus 1 all divided by these one will be cancelled, x raised to n into x raised to n plus 1. Why did I do that? Now if I substitute, listen, after substitution you will understand why did I do that. Listen, if I substitute t is equal to x raised to n, what is the derivative of t? dt by dx is equal to nx raised to n minus 1. Then dt is equal to nx raised to n minus 1 into dx. So nx raised to n minus 1 into dx, I got it here as dt. Substitution is possible. And these two x raised to n we can substitute as what? T. So let me perform that substitution. Integral all these things, nx raised to n minus 1 into dx become what? Dt 1 by what it is? X raised to n become what? T. T into t plus 1. Ready? Now we can perform partial fraction. How do we do that? Listen very carefully. This is your first factor. This is your second factor. Ready? So 1 by t into t plus 1 can be written as a by t plus b by t plus 1. Ready? I want to find a and b here. So multiply this entire equation with the denominator of LHS. So you will get 1 is equal to a into t into t plus 1 all divided by t, b into t plus 1 all divided by t plus 1. We can cancel these two and these two, and a into t plus 1 plus b into t will be there. Now let me substitute t is equal to minus 1. If I put t is equal to minus 1, 1 is equal to a into minus 1 plus 1, it become what? 0 plus b into minus 1 become minus b. So b is what? Minus 1. You got b is equal to what? Minus 1. And when you put t is equal to 0, what you will get? This becomes 0. So 1 is equal to a. 0 plus 1 is 1. 1 into a is equal to 1. Ready? Now let me do the rest of things is here. So I is equal to, instead of writing 1 by t into t plus 1, I'll write a by t. What is a? A is 1. 1 by t. I'll write 1 by t, b by t plus 1. What is b? Minus 1. Minus 1 by t plus 1. Minus 1 by t plus 1 dt. Listen very carefully. Instead of writing what? 1 by t plus 1. Instead of writing 1 by t into t plus 1, I'll write a by t plus b by t plus 1. Just replace this with the a and b that we already found. So what is integral of 1 by x? Integral of 1 by x is what? Log mod x. Integral of 1 by t is what? Log mod t. It's also like 1 by t, like, because derivative of t plus 1 is also 1. Derivative of t is what? Also 1. So log mod t plus 1 plus c. Log a minus log b is what? Log a by b. Log t by t plus 1 plus c. And what is t? Log mod. What is your t? T is x raised to n. Log mod x raised to n by x raised to n plus 1 plus c. That is your final answer. Okay, this is how we perform what? Partial fraction. I'm explaining the partial fraction part again. So take that rational function here and split the factors into a by t plus a by t plus 1. Then find a and b, put a and b here. Instead of this one, use this one and integrate. Easily you can do that. This is how we use partial fraction. We can go for the next question. Okay, what is our next question? Next question is the integral x plus 1 by x square plus 1 into x. So I is equal to what? I is equal to what? Integral of x plus 1 by x square plus 1 into x dx. How to solve this one? Listen, before, this is also partial fraction question, but before that we have to do some alterations. I split the denominator for both of them. I'll write like x by x square plus 1 into x plus 1 by x into x square plus 1 dx. I split the denominator for both the x and 1 and I can cancel these two. So what I'll get? Integral of 1 by x square plus 1 dx plus integral 1 by x into x square plus 1 dx. So this one you already know. This is what? Tan inverse x plus c, plus we don't know this one. We have to do this with the partial fraction. So I'll call it I1. So I will only get if you got I1 also. So listen, let me do the I1 here. So what is I1? I1 is equal to integral 1 by x into x square plus 1 dx. So let me split it. Let me do the partial fraction. It's like this is first degree and this is second degree. So a by x plus b by second degree is what? The second one is second degree polynomial. So we are not allowed to use just b. We have to use a first degree polynomial, that is bx plus c. Ready? Then we multiply the entire equation with the denominator. What you will get? 1 is equal to a into x square plus 1 plus bx plus c into x. Ready? When you put x equal to 0, what you will get? 1 is equal to 0 plus 1 is 1. 1 into a is a, plus b into 0 is what? 0 plus 1 is 1, and 0, x is already 0. So when you multiply it with the 0, this entire thing become 0. So you got a is equal to 1. How to get b? Here another method, we can find a and b and c. I'll show it. While opening the bracket, what you will get? Ax square plus a constant, and the constant is a, and bx into x, you will get bx square, and cx, that is a cx term. These are the terms. Let me write the constant here. Okay, plus a. Listen. So if I take the x square out, what I will get? A plus b plus cx plus a. Here it is only constant term only here. Ready? So we already got a is 1. The constant term, when you are equating the constant term, you will get what? 1. And a plus b is the coefficient of what? X square. We don't have x square term at the left side, so we can write it as 0. And c also become what? 0, because there is no x term. So in a plus b is 0, a is already 1. If a is 1, then b become what? Minus 1. So we got a, b, c. Now we will substitute that here. What we will get? I1 is equal to integral. Instead of this one, I'll use this one. In that we got a, b, c. What is a? 1 by x plus, what is b? B is what? Minus 1. X minus 1 into x is minus x, plus c is what? 0, divided by what? X square plus 1 dx. So let me integrate this one. Integral of 1 by x dx minus integral of x by x square plus 1 dx. So you can see, let me put a 2 here and balance it with 1 by 2. Balance that 2 with 1 by 2. Then only I'll get the derivative of x square plus 1 is what? Derivative of x square is 2x. Now the derivative of the denominator is at the numerator. We have done that one. Integral of f dash of x by f of x. Remember, what is it? Log mod f of x. Remember this equation? So the derivative of the denominator is on the numerator if we balance like this. So then derivative of 1 by x is what? Log mod x minus half integral of f dash of x by f of x is what? Log mod f of x plus c. And finally log mod x minus this 1 by 2 goes to the numerator, like n log x is equal to log x raised to n. So you will get log of x square plus 1 raised to 1 by 2. I can write it as root plus c. Log a minus log b is what? Log a by b, that is log of x by root of x square plus 1. That is your I1. Hence finally your I will be equal to tan inverse plus I1 log mod x by root of x square plus 1 plus c. This is how, these are the questions that you can expect from what? Partial fraction. Simple part, take the fractions here and separate the factors like this. If there is second degree polynomial, create a first degree polynomial at the numerator. If there is a first degree polynomial at the denominator, only write a constant at the numerator. That are the logic, and you know how to find these a, b, c using just basic mathematics. Put that here and just directly integrate that thing. This part is direct integration. Okay, so we can go for the next part. So this part is integration by parts. Integration by parts. Listen, what is integration by parts? If two functions are multiplied together, first function, second function. If two functions are multiplied together and substitution is not possible, substitution is not possible, then only do that. If substitution is not possible, then only do integration by parts. If substitution is possible, you can do, if two functions are multiplied together. Listen, we have done one. Listen, look at here. In this question you can see first two function is there. Two functions are multiplied together, but if you substitute this one, you can simply integrate it. We already done that. But if the substitution is also not possible, two function is multiplied together also. So what we have to do? We have to go for what? Integration by parts. When you will use integration by parts, you will only get question like what? You will get a question like this and integrate. You have to know how to do substitution of integration by parts. First of all, try substitution. Can you find some function, substitute it, differentiate it? When the derivative is in the function, you can continue what? Substitution. But if the substitution fails, integration by parts is the only way. So first function, second function, and the equation for integration by parts is what? First function into integral of second function minus integral of derivative of first function into integral of second function all dx. First function into integral of second function minus integral of derivative of first function into integral of second function all dx. Okay, also from this part, using integration by parts, we have derived one another equation. What is it? Integral of e raised to x into f of x plus f dash of x dx. Function is there plus f dash of x is there. E raised to x into f of x plus f dash of x. You can write e raised to x into function. That is your answer. We derived this equation from using integration by parts. So listen, we can do one problem, then only you will understand this one. So here, this is the special case. I is equal to, this question is based on this special case. E raised to x into function plus derivative. And answer is e raised to x into function. So how do we do that? Integral, e raised to x is out there. Then in a question, the e raised to x is out there. Then some functions is inside. Try to bring f of x and f dash of x, sum of f of x and f dash of x inside it. So here what I can do, x log x plus 1 at the numerator, divide it, split the denominator. Then what you will get, e raised to x, these two will be cancelled, log x plus 1 by x. If it is f of x, log x is f of x and derivative of f of x is there, that is f dash of x, 1 by x. Then the answer will be e raised to x into f of x, e raised to x into log x plus c. So you will get some questions like this. E raised to x will be there at the outside. Then inside there will be some functions. You just simplify it into f of x and f dash of x. Then you can write e raised to x into f of x as the answer. So this is some part of integration by parts. Next one, we can do a direct question from by parts. Here we have to use by parts and substitution little bit. So listen, there is two kind of functions here. It's equal to integral x by root of 1 minus x square cos inverse x. If you want, you can substitute this as two functions, or we can perform a substitution, then we can go for try substitution, then we can go for what? Integration by parts. So cos inverse x, I'm going to substitute t as cos inverse x because the derivative of cos inverse x is what? 1 by root of minus 1 by root of 1 minus x square, it's there. So derivative of cos inverse x is what? Minus 1 by root of 1 minus x square. So we have 1 by root of 1 minus x square here. I have took the negative in the list, this side. Minus dt is equal to 1 by root of 1 minus x square into dx. Okay. Then we need x, but here we don't have x. But you can build x from here. How? You can take this cos inverse to this side. Our last session is about inverse trigonometry. You can see that if you are not getting this idea, you can take this cos inverse to this side. Cos t will be equal to what? X. Then let me perform the substitution. I is equal to integral. Instead of x, I'll put what? Instead of x, I'll put what? Cos t. Okay. Instead of cos inverse x, I'll put what? T. Cos t into t, or t cos t. I can write it like t times cos t. That is perfect. And dx by root of 1 minus x square, dx by root of 1 minus x square is minus dt. Again, there is two functions. And when you're doing integration by parts, you have to follow the I-late rule. I-late rule. Inverse trigonometric functions, logarithmic function, algebraic function, trigonometric function, exponential function. Okay, so in this one, this is algebraic and this is trigonometric. Algebraic comes first, then second comes. So we consider this as t, and sorry, this as first function, and this as what? Second function. T as your first function and cos t as your second function. Ready? If it is e raised to x into cos x, what do you have to use? E raised to x is what? Last letter, so take it as second function, and this as first function. Always follow I-late. Then how do we do that? There is a negative outside. Okay, so what is integration by parts? First function into integral of second function minus integral of derivative of first function into integral of second function all dx, but here it is all about dt. So the answer will be, there is a bracket outside with the negative. I'll put a plus c here for the integration. So t, integral of cos t is what? Sin t minus integral of derivative of t with respect to d, with respect to t is what? 1 into integral of cos t is what? Sin t dt minus of t sin t minus integral of sin t is what? Minus cos t plus c. Open the bracket with the negative, you will get this negative, and negative become what? Positive, and opening with the negative you will get what? Negative cos t, and this also become what? Negative t sin t. The better way to write this is you can take the negative out, that you can keep the negative outside. That is the best way. Okay, so negative of what is t? T is cos inverse x. And before that, let me write it like t into this sin t can be written as 1 minus cos square t plus cos t plus c. You may think, why did I change that? Because we have t as cos inverse x. If we put cos of the t is what? T is what? Cos inverse x. If we put that inside this t, this cos and cos inverse will be cancelled. That is possible here, but not possible here because the outside function is what? Sin. So we changed that in terms of cos. That's why I have done that. So in this side also I am going to put that t is what? Cos inverse x root of 1 minus cos of cos inverse, cos of cos inverse x square. Okay, then there will be a negative outside. So negative of cos inverse x root of cos inverse cancelled, then you will get x only, 1 minus x square plus x plus c. Ready? Or you can just write x minus cos inverse of x into 1 minus x square plus c. That is the final answer using integration by parts. Always focus on this one. Keep what? I-late for the selection of first function and second function. And what is that equation? What is that equation? For integration by parts, integral of f of x into g of x dx is equal to f of x first function into integral of second function minus integral of derivative of first function into integral of second function dx. Okay, now we can go for the next part. Okay, the next part is integrals of some more types. Some more types means we have done lots of we derived some equation, new equations, 3 plus 3 equations, variations from it, integration by partial fraction, integration by parts. After all these, we derived 3 more equations. It's little bit similar to the 3 plus 3 equations without numerator. There is no numerator, sorry, there is no denominator, only numerator. There is no one or polynomial, whatever it is, nothing is there. It's just what? Root of x square minus a square, or root of x square plus a square, or root of a square minus a square. Remember these patterns, polynomials in this form, second degree polynomials in this form, without any numerator. Okay, so listen, if it is root of x square minus a square dx, x by 2 into root of x square minus a square minus log mod, this one is what? Remember, this one is what? 1 by root of x square minus a square, that is there. And this one is what? 1 by root of x square minus a square. And this one is what? Sin inverse x by a is what? 1 by root of a square minus x square. So it is very related to what? The questions, the equations in 3 plus 3 format with the root. Okay, so let me do one question using this one. Okay, then you will understand this one. So we have a question here. I is equal to integral root of x square minus 8x plus 7 dx. Listen very carefully, it's not of any of these 3 formats. So we have to make it in any of these three formats using this method, half of coefficient, completing square method. Ready? Completing square method. How do we do that? Listen, x square minus 8x plus 7, x square minus 8x, I'll write the constant 7 here, and let me add half of this 8, that is 4, square of half of coefficient of x minus 4 square, add and subtract, and this part will become x minus 4 the whole square and minus 16 plus 7. So x minus 4 the whole square minus 9. So x minus 4 the whole square minus 3 square. So in this case, I think you remember x, it is plus. So that's why I put here plus. And here in this case, it is x square. Here it is minus. That's why I put minus here. And the next term is what? The one which we take, half of coefficient of x. That will come under here. So x minus 4 the whole square minus 3 square. Now your polynomial is of the form that we need. Now I is equal to what? Integral. Instead of this polynomial, I'll use what? X minus 4 the whole square minus 3 the whole square. The one who replaced x is what? X minus 4. Which format? Which format? Sorry. Which format? Root of x square minus a square. It will be x by 2 root of x square minus a square minus a square by 2 log mod x plus root of x square minus a square plus c. So listen, here instead of x we have x minus 4. The derivative of x minus 4 is 1. So we don't need to do substitution here. So I is equal to x by 2 x minus 4 by 2 root of this thing itself. This thing is what? This thing is what? It's a polynomial. You can write the polynomial, that looks good. Okay, minus a square by 2. A square is what? 3 square by 2 log mod x. Instead of x we have x minus 4 plus root of the polynomial x square minus 8x plus 7 plus c. Ready? So this is your answer. You can, if you want, you can write this 3 square as 9 by 2 log mod x minus 4 root of x square minus 8x plus c. Okay, plus 7 plus c. So that's all. No need to simplify this. You are not able to simplify this. They may give you some option for this one. You can expect this question as an MCQ because it's simple. basic calculation is there, but not that much properties of integrals. If you know this result, if you can do this completing square method, it's from 9th or 10th grade, then you can directly apply that into there. No simplification needed for this question. So very easy question, you can expect as MCQ. So next one. So these kind of questions we will discuss in application of integrals. So I'm not adding more questions here, I'm just giving you can expect this kind of question only. The rest of the problems will be at the chapter application of integrals. Okay, so now we can move into the next part. The next part is definite integrals. So all the questions we have done just before is just integrating, but in definite integral there will be what? A limit from a to b. What is fundamental theorem of integrals? This is a fundamental theorem. There is two theorems, I'm just explaining first one. The second one, the first one we can explain the application of integrals because it's a little bit of related to areas and something, so we don't need that here. So what is this fundamental theorem? Integral a to b f of x dx means the derivative of f of x, I write it as what? Capital F of x, and the limit is from a to b. First we apply the upper limiter to the answer f of b minus lower limit. Apply the lower limit. Let me do one problem, then your confusion will be over. So I is equal to integral minus pi by 4 to pi by 4 sec square x dx. So first you differentiate the way you differentiate. Okay, it's just direct differentiation. Integral of sec square x dx is what? Tan x to the limit minus pi by 4 to pi by 4. Okay, so first we have to apply the upper limit. How do we apply the tan of pi by 4? Minus, apply the lower limit, tan of minus pi by 4. Tan minus pi by 4 is what? Minus tan pi by 4. Or you can directly apply the value 1 minus 1. So tan pi by 4 is what? 1 plus minus will become plus. Tan pi by 4 is what? 1. Then your answer will be 2. So always apply the upper limit first, then the lower limit. Okay, that is fundamental theorem of calculus. So listen, next question. Here is one more question that you can use what? Using definite integrals. Integral of 0 to pi by 8 tan square 2x dx. So here there is a trigonometric application also here. I think you all know 1 plus tan square theta is equal to sec square theta. So tan square theta will be equal to sec square theta minus 1. We don't know how to differentiate tan square to x. So, but we know how to integrate sec square. So instead of tan square, I can write it like sec square theta minus 1. So here it is 0 to pi by 8 sec square theta minus 1 dx. When you differentiating, derivative of sec square x is tan x, but it is 2x. What is derivative of 2x? It's 2. I divide it. I explained why. How do I do that? How did I do that? So derivative of 1 is, so integral of 1 is what? X to the limit 0 to pi by 8. So apply the limit, upper limit. Apply the upper limit first. 2 times pi by 8. 2 times pi by 8 divided by 2 minus 0 minus lower limit tan 2 into 0 0 by 2 minus 0. This whole thing becomes 0. Then your answer will be, this will be pi by 4. Pi by 4, tan pi by 4 is what? 1 by 2 is your answer. This is easy. Okay, apply the upper limit first, then the lower limit. Okay, now we can check the next part. Listen, one more question using definite integral. Listen, I is equal to what? Integral of 2 to 4 x by x square plus 1 dx. What is derivative of x square plus 1? What is derivative of x square plus 1? It's 2x. So if I put 2 here, if I balance this here, we'll get again that equation, integral of f dash of x by f of x. Very important equation. You can reduce so much of your time. You can do it using substitution, but without substitution, if you know this equation, you can directly do it. Okay, so what is it? It's equal to half derivative of integral of f dash of x by f of x is what? Log mod f of x 2 to 4. So half is there. Apply the upper limit first. Log of 4 square plus 1 minus log of, apply the lower limit to 2 square plus 1. Hence half log a minus log b is what? Log a by b. Log 16 plus 1, 17 by 5 plus c. Sorry, there is no plus c for definite integral. There is no plus c for definite integral. Okay, definite integral is giving you the exact values, not any random arbitrary constants. Okay, now, so the last part of this video is from properties of definite integral. You know, this properties comes under definite integral. There is 7 properties. First one is integral a to b f of x dx is equal to a to b f of t dt. That means if it's a definite integral, if there is a limit a to b and the limit is same, it doesn't concern about the variable, integrating variable. You can use t, z, you can write it what also, integral a to b f of z dz. Everything is what? Same. And integral a to b f of x dx is equal to negative of b to a. If you want to switch the limits, at that time you can take a negative out. And integral a to b f of x dx, if this is a and this point is b, in between there is a point c, then you can integrate from a to c. You can integrate from a to c f of x dx, then c to b f of x dx. You can split the integrals. And property 3 is integral a to b f of x dx is integral a to b sum of the limit a plus b minus x. Both are equal. Integral 0 to a f of x dx, it's like 0 to a for the property 3, it will be 0 and a. So 0 plus a is a minus x, so f of a minus x. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x. These two properties are very important. And integral 0 to a f of x dx, 0 to 2a, instead of just a, now we have 2a. It will be equal to integral 0 to a, just 1a f of x, plus integral 0 to a f of 2a minus x f of x, f of 2a minus x dx. Okay, so that there is some variety of this one. 0 to 2a f of x dx is equal to 2 times f of x dx. If f of 2a minus x is equal to f of x, this thing is becoming f of x, then you can write 2 times integral 0 to a f of x dx. And if that thing is f of 2a minus x is equal to negative f of x, instead of f of x, if it is negative f of x, the answer will be 0. You don't need to integrate, you can just write what? 0. And the 7th one is integral minus a to a f of x dx is equal to 2 times integral 0 to a f of x dx. If f of minus x is equal to f of x, or we can say it's an even function. If it's an even function, integral minus a to a f of x dx is equal to 2 times integral 0 to a. If it's an odd function, that means f of minus x is equal to minus f of x. It will be integral minus a to a f of x dx will be 0. Actually, properties is you have to pause the video. You have to go through the properties multiple times, then only you will understand. Do 1 or 2 questions from each property, then only you will understand. You don't expect to do 2 problems and understand all the properties, it won't work. Do at least 2 questions from each property, then only you will get to get into these properties. Okay, so let me do some of the questions from it. So here, integral minus 1 to 1 mod x minus 2 by x minus 2 dx. We need to integrate it. We never integrated mod x. If you get a question in integrals with mod x, that is definitely using a property. Which property? This property, property 2. Integral a to b f of x dx is equal to integral a to c f of x dx plus c to b f of x dx. Listen here. So first of all, why we need to use that property here? Actually, we don't know how to integrate mod. Actually, this integration is from minus 1 to 1, isn't it? You can see. When does this mod of x minus 2 become 0? When you're putting 2 is outside it. 2 is outside it. When you put 2, what happens? When you put 2, it becomes 0. Mod of x minus 2 becomes 0. When you put a number greater than 2, what happens? If you put 3, it will be 3 minus 2, it's 1. So you don't need to change the sign. What is the purpose of mod x? It changes the sign. If the negative is inside, it will change into positive. So if you put 3, it's already positive, nothing is doing. You don't need to use the mod at all. You can just write what, x minus 2. But if you are taking a number less than if you are taking a number less than 2, suppose it's 0. If it's 0, when you're putting 0 here, you are getting minus 2. So what happening? The minus 2 is become 2 when the mode will change the negative sign to positive sign. So who can change the negative to positive? Only negative can change the positive to negative. So instead of writing just x minus 2, I can write what? Negative x minus 2. Or I can write mod x minus 2 as two functions. One function is x minus 2, another function is minus x minus 2. This minus x minus 2 is when x is less than 2. This is when x is greater than 2. Actually, the mod function is collection of two functions. Actually, it is two lines will not make a function negative or positive. Actually, this negative is making the negative values into positive. So these two functions combined together we call what? Mod. So this side of this function, the function is minus x minus 2. But your function is having a denominator x minus 2. So this is your f of x. So actually your function is what? Minus 1. Ready? So integral minus 1 to 1 mod of x minus 2 by x minus 2 dx can be written as integral minus 1 to 1. In this particular interval, your function is just what? Minus 1 dx. In this particular interval from minus 1 to 1, your function is minus x minus 2 by x minus 2. You can cancel these two x minus 2s, you will get minus 1. Ready? Suppose, then you can directly integrate it. What you will get? Minus x to the limit minus 1 to 1. So you will get you can put upper limit first. So minus 1 minus minus 1, you will get minus 2 as your answer. You will get minus 2 as your answer. But the problem is, listen, when the limit is not minus 1 to 1, suppose the limit is suppose this question is like minus 1 to 3 f of x dx. At that time, you know, from 2, at the point 2, your function is minus x minus 2, and after 2, your function is x minus 2. So you have to integrate from minus 1 to 2. At that time, you have to write minus x minus 2 by x minus 2 dx plus 2 to 3. After 2 to 3 means you are going for what? After 2. So x minus 2 by x minus 2. The function is split into two parts. Ready? So you can write minus 1 to 2 minus 1 dx, 2 to 3 1 dx. Now you can easily directly integrate it and you will get it. This is where you use the property. You can split the integral. You don't need to integrate directly from minus 1 to 3. You can split between it, minus 1 to 2 and 2 to 3. Whenever you're getting a question with mod, you have to use this property. Okay. Next question is what? It's an assertion and reason question. Integral 2 to 8 root of 10 plus 10 minus x by root x plus root of 10 minus x. Listen, here you have a and b, right? When you add these two, you are getting 10. In a question, if you find these similarities, you have to use adding the limit. Adding the limit, you are getting something inside the question. So there is a property that adds the limit. If there is integral a to b, look at here. If there is integral a to b f of x dx, integral a to b f of x dx, limits are added together. So we have to use this property there. So let me do that. Let me write the limit. Let me write the property here again. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. If I apply that to this question, I is equal to integral 2 to 8 root of 10 minus x by root x plus root of 10 minus x dx. So I have to replace all the x with the sum of limit minus x. I have to replace this x with the sum of limit minus x. So what I'm going to do, integral 2 to 8 root of 10 root x root of 10 minus. So instead of this x, I'm going to replace some of the numbers. 2 plus 8, I can write it 10, 2 plus 8 minus x, 2 plus 8 minus x. So what I'm getting, 2 to 8 integral 10 minus 10 plus x by 10 minus x plus 10 minus 10 plus x. So these 10s are gone, and you're getting I as what? Integral 2 to 8 root x by root of 10 minus x plus root x dx. Now you can see the denominator of the question and the denominator of the one that we got after applying the property is same. The denominators are same. Whenever you're getting a question like this, the denominators will be same. So I'm going to add this I and this I. So you will get 2 to 8 dx. The denominator is common, that is root 10 minus x plus root x. And I have the numerator is what? Root of 10 minus x plus this numerator is root x. So these two will be cancelled. You will get 1. You will get 1. So 2I is equal to 1. 1 integral of 1 is what? X to the limit 2 to 8. So upper limit 8 minus lower limit 2. So 2I is what? 6. So you will get I as what? 6 by 2. So I is what? 3. You got 3. So in this question, come to this question, integral of this thing is what? 3. They have given. The reason is integral a to b f of x dx is equal to integral a to b f of a plus b minus x. Yeah, this property is the reason that we got 3, isn't it? So both a and b are true, and r is the correct explanation of a. So this is how you use properties. Okay, I'm not going to do all the type of questions right now because already this chapter is very long. We have done lots of questions. So you can find different kind of questions for these properties from your NCERT or previous year question papers. So do all that questions. If you have any doubts, just comment below in this video. We will reply for that, and also you can contact Excel for the admissions, and if you have any doubts you can just contact Excel and you can get me. Okay, so that's all. See you in the next video. Bye.